Rick McKenzie. I'm in Old Dominion University in a department called the Modeling, Simulation, and Visualization Engineering Department. So you'll see this acronym MSVE. And our department information can be found at odu.edu/MSVE, and much of this information will be on there. But I want to talk about what we're doing to provide modeling and simulation programs to the community and actually to the world. Our classes are hybrid, meaning we teach them live, and they're also can be participated online remotely. They're recorded, and you can watch them later on, and it spans the whole semester. So I'll talk about, that's why I have here on-campus and online programs. Personally, my training is in computer engineering from the University of Central Florida with a concentration in artificial intelligence. And I came here specifically to talk about and teach in the programs that the university has in modeling and simulation, which are quite extensive. If we can go to the next slide, please. So we offer programs in M&S, or modeling and simulation, from the engineering college. That's why this is modeling and simulations engineering and MNSE. And it's essentially a program of study in computational science and engineering that focuses on the modeling techniques and the simulation techniques that drive towards training and decision support. So realistic models, not necessarily for entertainment, realistic models that are used to get a real answer, train people to have a transfer of training. Next slide, please. So this slide has 3 rows here, and the boxes are different classes. And what I mean to show here is our undergraduate program and how it's broken into 3 areas. And the top row you see says software development, which means our students are excellent programmers and know how to build the models and build the engines that drive the models and create a simulation. And then the middle part is the modeling and simulation core. So what are the different types of models, how to develop them, how to use them. And there are 2 boxes in that middle row all the way to the right, and that is a year of senior design which culminates in an experience, in a real-world experience in designing a system that has to do with modeling and simulation. And the next speaker will talk about systems that were developed as part of this 1-year experience by our students. And then, of course, the bottom row is analysis, which is a significant amount of math and statistics that are involved in building and analyzing, verifying, validating these models. And of course, this is the only program in the world at the undergraduate level that's also ABET accredited. The ABET is the accreditation board for engineering and technology. We also have graduate programs at the master's and the doctoral level, and these, the slide is a little bit messed up, but these include a set of leveling courses, a set of core courses, and then the master's and dissertation, master's thesis and dissertation options. I wanted to mention a specific example of people that are utilizing our programs, and this particular one is a graduate certificate in modeling and simulation, and it's 4 courses, And we've been providing this to the Naval Air Command at Pax River in Maryland for a number of years, as you see there on the bottom of the slide. And the number of courses that are taken as part of this are shown there. And if you go on to the next slide, these students also go on to get their master's in modeling and simulation with us, and it's those 4 courses that they take, plus they take 6 more courses, and here are the 6 courses that this particular cohort is of Navier students are taking, which includes an introduction to AI, visualization, synthetic environments, and model engineering. So that's what I wanted to mention. It was about our research and efforts in modeling and simulation. The research is too much to talk about here. I can mention briefly my area. I do have a background in military simulation, but I do mostly now medical modeling and simulation. For example, one of my projects is looking at chest deformities and scanning them in 3D and detecting the curvature of the deformity to try to classify them and categorize them into a particular type of disease, as well as the dynamic aspects of that. How do they look when the patient is breathing? And this will allow a better use of particular treatment techniques for a particular patient. And with that, I will yield to the next speaker. Thank you.